The plates going on all the time around the planet's surface.
Geologists call this dance plate tectonics. The planet's internal heat moves the huge plates. Above the hottest zones, molten rock rises and solidifies, creating new crust. The new crust jostles for space, forcing crust on cooler edges to grind against other plates or push beneath them. But wherever or however plates collide, they generate earthquakes.
Earthquakes happen because these huge chunks of rock that form the Earth's plates don't slide against one another nice and smoothly. They stick and they lock. So you're getting this enormous accumulation of strain, and then you're getting it released in a matter of seconds during the earthquake.
The quakes can originate tens of miles down, but the energy they generate creates deadly vibrations on the surface.
The amount of energy generated in the biggest earthquakes are comparable to many, many thousands of nuclear bombs going off. There's a huge amount of energy, absolutely vast.
Haiti lies directly above a network of massive faults, where the Caribbean plate meets the North American plate. As the plates slowly creep past one another, the rock distorts and stretches like rubber, building up enormous stress. Since 2003, Calais and his colleagues used ground movement data to calculate stress levels at the plate boundary. Calais realized a deadly quake was inevitable.
What we saw was a fault being loaded, just like a rubber band.
Simple math allowed him to calculate the precise elastic strain on the fault.
The last earthquake on that fault occurred about 250 years ago, and it's building up elastic energy at 7 millimeters per year. 7 times 250 is about 1.8 meters.
That's almost 6 feet of stored strain, equivalent to 100 Hiroshima atom bombs. Seismologists use a logarithmic scale to measure earthquake strength. Each number indicates a seismic wave 10 times larger than the number below. A 2 is insignificant, but a 7 or above can be immensely destructive. In 2008, Calais announced the Haitian fault could generate an earthquake above magnitude 7. 2 years later, his forecast proves accurate.
Breaking news from Haiti tonight, where a massive 7.0 earthquake struck.
A major earthquake measured at 7.0.
History has crippled the country, measuring 7.0.
Calais came closer than anyone to giving an accurate warning of the quake. But like all seismologists, he had no idea exactly when it would happen.
We cannot predict earthquakes. We had no way of telling whether it was going to be today, tomorrow, in 10 years, in 100 years, so we didn't put a date on it. And it's not that we were afraid to put a date on it, as a scientist, we can't.
Today, seismologists can calculate the pressures on the plate boundaries, but they can't predict when the faults will rupture.
We can't see earthquakes coming, that's the problem. 1 minute they're not there, the next minute, wham.
Back in the lab, Calais now attempts to find out how much stress remains in the Haiti fault. It's bad news.
We saw on January 12th that only a small portion of the fault actually ruptured. The fault itself, from the Dominican Republic all the way to the western end of the southern peninsula of Haiti, is about 300 kilometers long. And it's only a segment of 50 kilometers in the middle that released its energy during the earthquake.
The rest of the fault remains under stress. Calais predicts that segments even closer to Port-au-Prince could snap at any time.
Those segments have been brought slightly closer to the next earthquake. Again, what's the timeline? We don't know.
Port-au-Prince is not alone in its predicament. Anywhere on the globe above an active fault is vulnerable. And the faster the underlying plates move, the more frequent the quakes. The Middle East, South Asia, China, the Pacific Rim. In the absence of prediction, these zones remain some of the world's deadliest places. And let's not forget, California, home to the San Andreas Fault. This infamous fault system stretches 800 miles. From Northern California to the Mexican border. Like the fracture under Haiti, it's a vertical strike-slip fault, meaning the plates grind past one another horizontally. But here, the plates move more than 3 times faster, at over an inch a year, generating powerful earthquakes. In the south, some sections have been quiet for over 150 years. Now, satellites measuring ground shift reveal a buildup of stress energy equivalent to 3,000 nuclear bombs. The next rupture could be the big one. And it's the LA region